As you can see, this is probably the longest assignment that I've given you all year long, and probably it will be the longest one for the entire year after this as well. But the reason for this being such a long assignment is because, for whatever reason, logarithms seem to be a subject that many students try to avoid, and once they learn it, they don't have an easy time remembering. Anyway, so I'm just going to go ahead and do some of the problems. And the problems that I'm going to be doing are the ones, if you look in your book, they're the ones that are in, looks like orange, kind of an orange color. And you can see each separate section has its own problem that I'm going to go ahead and just do those. And so it's just to refresh your memory of how to do these problems. You got all of this in Algebra 2, so this is all a review from Algebra 2. So let's go ahead and get started. And in problem number 9, we're changing this exponential statement to an equivalent statement involving a logarithm. And as we've talked about already, a log is an exponent. It's the exponent that you raise the base to get to the argument. So probably should point that out here. We have the base right here, the base. This guy right here is the exponent. And then we could call this the answer or the argument. Either one. I use argument when I'm referring to logs. So use the argument. So base, exponent, argument, or answer. Still starts with an A. And a log is an exponent, so the bottom line is if the base is 3, the 2 is the exponent, so 2 is the log. The base is 3, and the argument is 9. So basically, 9 equals 3 squared is the same thing as writing log base 3 of 9 is equal to 2, or 2 equals the log base 3 of 9. Similarly, in problem number 17, we see that we have a base. There's the base. And there we have our argument. Now this becomes our exponent. All right, so this is our exponent because a log is an exponent, and the exponent is the number that you have to raise the base to get to the argument. So if you understand that concept, it's hard to forget. Where all the numbers go, because many times students just try to memorize this, and this is if a to the y is equal to x, then log base a of x is equal to y. So this is much harder to remember than understanding, well, a log is an exponent, so that's the exponent. The base is right there, and you've got exponent. So if you try to understand conceptually why these two statements are the same, one being exponents and one being logs, then it makes it much easier to remember that. But this right here, by the way, this is the most important connection between that you can remember that helps you link exponential form to logarithmic form. All right, I'll stop the video there and I'll pick it up in the next one.